As you can see in this video, we're going to be looking at two-tailed hypothesis tests. So let's start with this question. According to the manager of Curtis's Confectionaries, 10% of the sales are from the website. A marketing expert revamps the website and claims that the proportion of shoppers using the website will be different. One day, 8 out of the random sample of 50 customers bought from the website. Is this significant at the 5% level? Now, in the previous video, we learned how to tell the difference between a one-tailed test and a two-tailed test by the wording in the question. Now, this one is a two-tailed test because it says a marketing expert revamps the website and claims that the proportion of shoppers using the website will be different. Not less than or greater than, different. So we know it's a two-tailed test. So what we do first of all with the two-tailed test is a 5% significance level, change it to a decimal. Because it's a two-tailed test, we must half it. So we must half the significance level. So it'd be 0.025. The first thing to do is to work out the null and alternative hypothesis. Now, the null hypothesis is what we currently believe to be true, and that's what the manager of Curtis's Confectionery is telling us. The probability of customers buying from the website is 0.1. Now, we're going to test to see if the probability of the proportion of customers buying from the website is different. So if it's not equal to 0.1. Now from here, what we do is very, very similar to what we do in a one-tailed test. We draw something like this, and we're going to say we've got 50 customers. So this is the number of customers. So we've got 50 customers, and out of those 50 customers, on this day, 8 people buy from the website. So this is the actual number of customers who buy from the website. Now, if the manager is correct, if we go with the null hypothesis, 10% of those 50 customers should buy from the website. So we're going to find 10% of 50, which is going to be 50 times 0.1, because that's 10% as a decimal, and it'll be 5. So we actually expect to get 5 customers buying from the website. That's our expected amount. However, we get 8. Now you'll remember that we always say is what you got or weirder. Now it's weirder when you go away from your expected value, because if you expect something and it doesn't go to where you expect, that's unusual. That's not what you thought it was going to be. So it's away from where you expected. So we're looking for the probability of x is greater than or equal to 8. Now you'll remember that your calculator can only work out less than or equal to's. So we need to change this using this formula. The probability of x is greater than or equal to a is equal to 1 minus the probability of x is less than or equal to a minus 1. Now in this case, a is equal to 8. So we're going to plug 8 into this formula. X is greater than or equal to a is equal to 1 minus the probability of x is less than or equal to 8 minus 1. And then we can simplify that. Probability of x is greater than or equal to 8 is equal to 1 minus the probability of x is less than or equal to 8 minus 1 is just 7. So this here is what we're going to type into our calculator. The probability of x is less than or equal to 1 minus 7. So we go to our calculator, we go to menu, 7, down to binomial CD, press 2, and then we're looking for 7 or less. The number of people surveyed was 50, and the null hypothesis was 0.1. Plug all that in, and then there's our value. However, we need to do 1 minus this value, so we just go back to the original screen and press 1 minus ARNS, and there's the value we're looking for. So it's 0.122 to 3 significant figures. Now we need to compare this to our significance level to see if we reject the null hypothesis. So there's our significance level. So we can say that 0.025, our significance level, is less than 0.122. I've just written this up here so we got a bit more room. Because our value is greater than the significance level, we say that there is insufficient. Remember, you get a mark for writing this statement, so write it every time. Insufficient evidence to reject H0. Now, if it was found that this was our value that we got was less than the significance level, then we'd say there is sufficient evidence to reject H0 in favour of the alternate hypothesis. Now we need to make a statement about the situation. So if we're keeping the null hypothesis, that means the marketing expert's claim is incorrect. So marketing expert's claim is incorrect. The website revamp hasn't increased the proportion of people buying online. Hasn't increased the proportion of online sales. So something along those lines will get you the mark, as long as you relate it back to the situation. Okay, this is the second part of the video, so I'd like you to pause the video here and give this question a go, and then I'm going to go through the answer. Right, let's go through the answer. Lydia is a keen bird watcher. Over several years, she has noticed that 15% of the birds she sees are robins. She has brought a new type of bird seed and she is not sure whether this will attract more or fewer robins. The next day, only 2 out of the 40 birds were robins. Using a 10% level of significance, test whether the proportion of robins she sees has changed. Now we know it's a two-tailed test because it says more or fewer. If it just said more, it would be one-tailed. If it just said fewer, it would be one-tailed. But because it says both, it's two-tailed. So we start by doing the null and alternative hypothesis. So the null hypothesis is that the probability of seeing a robin is 0.15, and the alternative is that the probability is not equal to 0.15. So as it's a two-tailed test, we must halve the significance level. So it was 10%, which is the same as 0.1 as a decimal. So we half that and we get 0.05. And from here on out, it's the same as before. So we draw something like that. This is 0 birds, this is 40 birds. Now, let's work out how many robins we would expect to see if this is true. So we have 40 birds, 15% of them are robins. Let's see how many that would be. So you can type this into your calculator, maybe you can do that in your head. It should be 6. So you expect to see 6 robins. However, on the next day, she only sees 2 robins. So down here is the actual. So we do what we got or weirder. We're going to go away from the expected value. Because if we expected to see 6 and we only saw 2, it's a bit strange. But if we expect to see 6, we only saw 1, that's even weirder. And if we expect to see 6 and we don't see any, then perhaps this new bird seed has affected the number of robins that we're seeing. So we're looking for the probability of x, right over here, we're looking for the probability of x is less than or equal to 2. Now that our calculator can do because it's a less than. So go back to binomial CD and we put in 2, there's 40 birds. The null hypothesis this time is 0.15. Press equals, and there's our answer. So to 3 significant figures, it's going to be 0.0486. 0.0486. Now we need to compare this to our significance level. 0.0486 is less than 0.05. Now because it's less than, we say that there is sufficient evidence to reject H0 in favour of the alternative hypothesis, in favour of H1, the alternative hypothesis. Now we need to relate it to the situation, so we could say the new bird seed has changed the number of robins which visit Lydia's garden, or that Lydia sees.